All right, it's time for our last video of the year. And so number one says the factor of the following polynomial. This is 3 terms. And so that's where we do the x method. On top, you put a times c, which on this one, your a is 2 and your c is 7. So it's going to be 14. On bottom is going to be the negative 9. It's your b. And you try and think what two numbers multiply to 14 and add to negative 9. And so in this case, it's going to be negative 2 and negative 7, which multiply to positive 14, add to negative 9. And lastly, you're going to divide by the a. So we're going to divide both sides by 2 and simplify if you can. So this one's going to be negative 1 over 1. This one stays the same. The bottom number is your x, and the top number goes with it. So x minus 1 is that one. And then 2x minus 7. Number 2, we're going to either use long division or synthetic. I'll go ahead and use synthetic. We're going to set this equal to 0. X equals negative 6. We'll put that in the box. And then we're going to list all the coefficients. So this has fourth, third, the first, and then no x. And so it's missing the x squared. So we're going to put in a 0x squared right there. So our coefficients are 1, 6, 0, 5, and 33. And then our process, we're going to drop down that first number, multiply to the box, and then add these together, and then multiply to the box, add these together, multiply to the box, add these together, and keep doing that all the way through. This last number right here is our remainder. Our degree was 4, our highest exponent was 4, and so this is going to be 1 less. So this is going to be my x cubed, my x squared, my x, and my non-x, my constant. And so these are nothing, and so I'm going to leave those blank. So we're going to have x cubed plus 5, and then my remainder plus 3 over x plus 6. Number 3, it says to use long division or synthetic division to determine that it is a factor, so that this is a factor of this. If it's a factor, the remainder will be 0, no remainder. So on this one, x equals 3. I'll put in the box. No terms are missing, so we're going to have 1, negative 3, negative 4, 12. Drop down that 1 and multiply. And so this one doesn't have a remainder, it's good. So this was x cubed, so this is x squared, my x, and my constant. And so we're going to have x squared minus 4. That's going to factor down, because then it says factor completely, to x plus 2, x minus 2, because of difference of squares. And then this factor was good, so we're going to drop that down as well, x minus 3. And so that's the final answer. And one thing to remember, the highest exponent was 3, which means I should have 3 answers, and so I should have 3 factors. So 1, 2, 3, we're good. That's my answer. Number 4, we're going to factor completely. The highest exponent is 3. So my final answer should have 3 factors. And this has 4 terms, so we're going to factor by grouping. And so I split it into 2 groups, and then we're going to do a whole bunch of GCFs, greatest common factor. So I can pull out x squared, and I'm left with x plus 3. I want these two to match, and so I need the signs to change. I'm going to pull out a negative 1, and I'm left with x plus 3, which now they match. So these two are going to come out together as 1. It's another greatest common factor. When you take out the x plus 3's, you're left with x squared minus 1. And that's going to factor down to x plus 1, x minus 1, and x plus 3 is still there. And so again, my exponent was 3. I have 3 factors. That works. All right, number 5, again, we're going to factor completely. We always look first for our greatest common factor. I can pull out an x from all of these. And also, I always want my lead term to be positive. So I'm going to take out a negative x from everything. So that's going to become positive x cubed minus 2x squared minus 4x plus 8. All right, now this is 4 terms, so I'm going to factor by grouping. And so we're going to pull out x squared from here. And I'm going to ignore the negative x for right now. I'm going to bring it down at the end, just so I don't have to keep up with all these double parentheses and everything. And so pull out x squared, I'm going to have x minus 2. I want these two to match, and so I'm going to pull out negative 4. It changes my signs and divides by 4, so x minus 2. These two are the same, so they're going to come out together. And you're left with x squared minus 4. And I'll bring down that negative x from the beginning. and then we'll factor it further using difference of squares right here. And so it's going to be negative x minus 2, and then x plus 2, x minus 2. And the only thing you can combine is there's 2x minus 2's. And so the final answer, I'll write it over here. We've got x plus 2, and then there's 2x minus 2, so x minus 2 squared. And that's 1, 2, 3, 4. My exponent is 4, and so we're good. Anytime you're adding or subtracting or solving with equals, you have to get a common denominator. So my LCD on this one, the least common denominator, is going to be 6. And so we're going to multiply this fraction by 2. This fraction is already good, and this fraction by 3. And so it becomes 2x minus 6 over 6 equals x minus 5 over 6 plus 3 over 6. Now that you have the common denominators, I don't need them anymore. We can just solve for x on top. And so we'll combine like terms over here. So 2x minus 6 equals x minus 2, because negative 5 plus 3 is negative 2. And then I want to get x's together. So I'm going to move this x over here by subtracting x. And I'll move this negative 6 over here by adding 6. And so we get x equals 4. This one is the sum of cubes, which the formula is a plus b, a squared minus ab plus b squared. And so this is my a cubed and this is my b cubed. And to find my a, we're going to do the opposite of cubing, which is cube root. And so to find my a, we're going to take the cube root of 64x cubed, which is 4x. To find the b, we're going to do the cube root of 27, which is 3. And so everywhere we have an a, I'm going to put 4x. Everywhere we have a b, I'm going to put 3. And so my answer is going to be 4x plus 3. Right here it's a squared, the whole thing 4x squared, which is going to be 16x squared minus a times b, and so 12x. And then plus b squared, which is 9. To simplify this one, we're going to multiply everything out and then combine like terms once we've done that. So 2x minus 5 squared means there's 2x minus 5's. And so we're going to FOIL this. And so 4x squared minus 10x plus 25. Then we're going to distribute this negative 2, and so we've got negative 14x squared minus 12x minus 16, and distribute this 3, and so 12x cubed minus 18x squared minus 18x. And now we'll go through and combine all of our like terms. So I'll start with the highest exponent. We got the 3 right here, and that's the only one, so 12x cubed, and that one's done. Now for our squareds, so we have 4x squared, that's going to make negative 10x squared, so negative 28x squared. And then our x's, we've got negative 10, so that's negative 20, negative 32, negative 50. And so done with all of our x's. And last one, just the numbers. We got 25 and minus 16, so plus 9. And that's the answer. Solve the log. There's 2 ways you can do it. I'll show both ways. And so 2 log x equals 8. Oops. And 2 log x equals 8. All right, so the first way, I think the easiest way, this 2 is being multiplied to the log. To get rid of that 2, we'll divide by 2. And so we get log x equals 4. If there's not a base written, the implied base is always 10. And so to rewrite this as an exponential would be 10 to the 4th equals x, which would be 10,000 equals x. The other way of working this out is you can make this 2. Anytime you have a number in front, it represents an exponent for this number right here. So log x squared equals 8. And again, we've got that. And so we're going to have 10 to the 8th equals x squared. And we're going to put this in the calculator. That's a 1 with 8 zeros. And then we're going to take the square root of 10 to the 8th, which again is 10,000. And so either way you do it, you're going to get the same answer. It doesn't matter, whichever you prefer on this one right here. Number 10, I'm actually going to do number 10 on number 13 because 10 and 13 ask you to graph the same graph, so I won't worry about 10. We'll just do it later. Number 11, rewrite this as in logarithmic form, and so it's going to be log, the base is 5 of 625 equals 4. And so that's the answer. Number 12, we're going to plug into this formula. And so the A is your final amount, P is the principal, the initial amount, R is that percent as a decimal, N is the number of times compounded per year, and T is the time. And so he wants $12,500. He currently has $3,000. He puts it into an account that gives 7.5%, so 0.075 divided by compounded monthly, that's 12 times per year. So my n's going to be 12 up here as well. And how long, I don't know the time, and so we'll keep that a t. So now to solve for the t, we're going to do two things at one time. The first thing we're going to do is we're going to divide by 3,000. And so we'll use the calculator right here, 12,500 divided by 3,000. Is that, I don't want to round until I get to the end, just so I keep my answer as exact as possible. So I'll change that to a fraction, 25 over 6. If you do round it, try and keep as many decimal places as you can write, just so that your answer is more exact at the end. We're also going to simplify this parentheses. And so 1 plus 0.075 divided by 12 is 1.00625 raised to the 12t. So now that this exponential is by itself, to get the exponent by itself, we're going to switch it to log. And so log base 1.00625 of 25 over 6 is equal to 12t. And so we're now going to put this in the calculator, and then our last step, we're going to divide it by 12. And so alpha window, we'll go into that log base, 1.00625 of 25 over 6. And then we're going to divide that by 12 to get the answer of 19 point, we'll say 1 years. Alright, so graphing this. You can always use a calculator. So this is what it looks like right here. It's kind of hard to see in the calculator. But if you were to go to the table, 2 points you can put in is 1, 1, and -1, -1. And then it's going to get closer and closer to the x-axis, but will never touch the x-axis. It's going to get closer and closer to the y-axis, but never touch the y-axis. And the same thing down below. And so it's got these opposite facing parabolas right here. It also has to describe the symmetry. For this symmetry, if I were to flip over the x-axis, this would come up here, this would come down here. They don't overlap. Flip over the y-axis, again, don't overlap. My two lines of symmetry for this one are this dotted line right here, y equals x. Because if you flip over this line right here, this would overlap with this would overlap with this, and so that's one of them. And then the other symmetry is this y equals -x. Which if I flip over this dotted line, all these points would come down to here, these would come up to here, they would overlap. So y equals -x. Those are my two lines of symmetry for a rational function. All right, number 14. Describe the transformation. This +3 on the outside goes up 3. That's it. 15. There's two ways of solving this one, so I'll show both of them. The way we solved this during Unit 9, I would get the same base, and so the same base would be 3. And so 3 to the 2x equals 27 is the same thing as 3 cubed squared. And so now we've got the same baseline, so I can get rid of that. 2x equals 3 times 2 is 6, and so x equals 3. And so that's one way of doing it. That's what we did in unit 9. However, I think this is probably easier now that we've done logs. And so 3 to the 2x is equal to, I'm going to go ahead and simplify, 27 squared is 729. And now using logs, I'll change it to log. So log base 3 of 729 equals 2x. And we'll divide this by 2 to solve for x. And so alpha window base 3 of 729, and we'll divide by 2 again to get 3. And so again, it doesn't matter which way you want to do it. This way is probably easier, but both get the same answer. Number 16, it says if x is replaced with x plus 5, so this whole thing's going in there, which means it looks like this. How's the graph changed? Well, it's attached to the x-axis, is going to go left 5. The domain of the function is my x's, and so it wants to know what are my x values for this function. And so we'll go ahead and factor this bottom portion. So we're going to see what multiplies to 16 and adds to negative 8, negative 4, and negative 4. My a value is 1, and so that's my new function. And so now we try and think, what can I not plug in for x into this function? And so the only thing that you cannot divide by is 0. And so can't divide by 0. So this denominator cannot equal 0. If it does equal 0, then it doesn't work. It becomes undefined, and it's an asymptote. And so for this one, if I set this equal to 0, x equals 4. And so my domain is all real numbers, but x cannot be 4. That's the only thing x cannot be. Number 18 wants to know what happens as the value of k changes. The k is going to be my vertical change, so it's going to shift up or down k units. So this one wants a vertical and the horizontal asymptotes. It's been a while since we've done this, but for the horizontal asymptotes, here's my 3 rules. If your degree in the numerator is less than the degree in the denominator, which remember degree is your highest exponent, then the asymptote is y equals 0. If your numerator and your denominator have the same degree, they both have the same highest exponent, your y is equal to your a over b, which your a and your b are the leading coefficients. So it's the leading coefficient on top over the leading coefficient on bottom. And if your n is greater than your d, if the numerator is greater than the denominator, as far as the degree goes, then there is no horizontal asymptote. That's where you're going to have a slant asymptote, and you can always graph it in the calculator to see what it looks like. So on this one, the degree on top is 1, degree on bottom is 1, and so that means they're equal, which means we're going to look at the leading coefficients. So let's see, the VA and HA. So the HA is going to be y equals, my top is 2, the bottom is 4, which equals 1 over 2. And so y equals 1/2. For the VA, we're going to set the bottom equal to 0 and solve to see what x cannot be. Because that's going to be my discontinuity. It's going to be my asymptote. So 4x equals 2, because I add 2 over. Divide by 4, and you get 2 over 4, which is 1/2 on this one as well. And so x equals 1/2. So there's my VA and my HA. All right, number 20. Find the value of x, and so we're going to isolate this cube root first. We're going to subtract 4 over, and then we'll divide by -2. And then to get rid of the cube root, we're going to cube both sides. And so x equals 27. If you're unsure, you can always plug it in and see if it works. And so -2 cube root of, we got 27 for x, plus 4, and we'll see, does it equal -2? Yes, it does, and so it checks. Describe the changes. -4 on the inside is going to go right 4, up 7. This one we're going to solve for x. My LCD, we've got a 3 and x squared is going to be 3x squared. So this one needs a 3. This one's good, and this one needs a 3x. The bottom tells me that x cannot be 0. Any other value would be true, but I can't divide by 0. So this is going to be 3x plus 15. We got a minus right here, which is going to change all my signs. So minus x plus 1 equals 3x. And so I'll combine like terms. That becomes 2x plus 16 equals 3x. Subtract the 2x over, and you get 16 equals x. And again, you can always check that if you wanted to. Number 23, list the x-intercept, the y-intercept, the symmetry, the domain, and the range. Alright, so I'll just go ahead and graph it real quick just so I get a good picture of what it looks like. I think with graphing problems, it's always a wise idea, a good choice to graph things in your calculator, see what it looks like. And so there it is right there. The transformations, it goes right 2 and down 6. And so that's going to be my symmetry. It's going to be rotational 180 degrees around 2, negative 6. Because that's that point of inflection. That's that turning point of this graph at 2, negative 6 right there. The x-intercept on the graph I can't really see. The y-intercept we can see though, and if you go into the table, you can see that it's about negative 7.26. Domain is all real numbers, and the range is all real numbers. It goes continuously all directions. All right, so finding the x-intercept, it's going to be well over there in the calculator, and so I'm going to solve it algebraically. I'll actually do both the x and the y-intercept. For the x-intercept, your y value is 0, and we're going to find what x is when y is 0. So we're going to plug in 0 equals cube root of x minus 2 minus 6, and we'll solve for it. So we'll add 6 over, and then we'll cube both sides. Let's see, 6 cubed is 216, and then we'll add 2 over, so x equals 218. And so the x-intercept is at 218. You could do the same thing finding the y-intercept by plugging in 0 for x. And so y equals 0 minus 2 minus 6 to see what it is. And we can just put this in the calculator. And it is that negative 7.26 that we also got in the table. And so here's how you can solve for the x and y-intercept using your calculator and your paper. All right, number 24. So this 3 in front is going to be a vertical stretch by 3. It would be a compression if that number was between 0 and 1, but it's greater than 1, so it's a stretch. We're going to go right 3 and down 4. All right, number 25, simplify. Just combine like terms. I'll go ahead and this minus right here is going to change all my signs. So minus 8x squared plus x to the 4th minus x cubed. And again, change all my signs. And so that's 1 too many arrows up there. Negative 4x cubed and negative 2. And now we'll combine all our like terms. So let's see, the highest one I see is x to the 4th. So we got negative 6 and positive 1. So negative 5x to the 4th. Let's see, 7x cubed. It's going to be 6x cubed. It's going to be 2x cubed. 7, 6, 2. There we go. My squareds, we have 7. And so that makes it negative 1. So minus x squared. 8x. And minus 2. Solve for x, and so we'll subtract 5 first. So negative cube root of x minus 4 equals, we subtracted 5, so negative 3. We'll divide by that negative 1 to get rid of the negative. And so cube root of x minus 4 equals 3. We'll cube both sides. X minus 4 equals 27. And then add 4 over, x equals 31. All right, so this is going to have a vertical stretch by 2, left 4, and down 3. And once again, we're graphing. I think it's a great idea to put in the calculator. And so we're going to have 2 in the front, cube root of x plus 4 minus 3. And so here's what it should look like. And now I'll make it happen. It's going to start at -4, -3, 1, 2, 3, 4, 1, 2, 3. Normally, when we go over 1, the cube root of 1 is 1. And so it'd go up 1. However, we got the stretch by 2. So we're going to go up 2. I'll just check this point in the calculator, make sure I got it right. -3, -1 is correct. And so we can actually, if wanted to, look for another point. There's another point right there, 4, 1. And then we don't have to worry about, did we get these rules right? We can just find it in the calculator. There's another one, -12, -7. So that's off my graph up here. So now I'll just make it look like the calculator looked. And so there's a good little picture of it. Number 28, anytime I see multiple logs, I always want to condense it to one log. And so this 2 is an exponent for the 2. And there's addition, and so they're going to combine with multiplication. So it's going to be log 2 squared times x times 3 equals, there's an exponent for the 6, so log 6 squared. Now since I have log on both sides, they can cancel out. And now we can just solve for x. So 2 squared is 4 times 3 is 12x equals 6 squared is 36. Divide by 12 and x equals 3. And last page. We want to go from logarithmic to exponential. And so we're going to get rid of the log, change it to exponential. So my base is 4 raised to the 6th power equals 2x plus 5. It doesn't ask us to solve, just rewrite. And so that's it. Number 30, the asymptotic behavior. So just the asymptote. If we want, we can look in the calculator. This one's kind of hard to see. The implied base is 10. And so it's kind of hard to see on this calculator. But if you were to zoom in, it's going to look something like this right here, where it never touches the y-axis. So the asymptote is the y-axis, which the equation for it is x equals 0. These are the same thing because everywhere on the y-axis, your x is always 0. It's 0, 1, 0, 2, 0, 3, 0, 4, 0, -10. It's always x equals 0 everywhere on the y-axis. And then last two describe the effects on the parent function. And so that's going to go left 2 and down 5. And the last one, solve the cubic equation. So we want to get this by itself. So we're going to subtract 5. Then we'll divide by 4. Then we'll take the opposite of cubed is cube root. And then we'll add 1 over and divide by 3, x equals 1. And since it's the last one, we'll go ahead and check it in the calculator, make sure we did it right. And so 3 times 1 minus 1 cubed plus 5, we'll see, does that equal 37? Yes, it does. And that is it. Hope everybody does well.